Wait for someone to give us some kind of confirmation. All right. In theory, we're live. Hey everyone, welcome to Monday's Open Space here on my YouTube channel. I'm joined by Susanna Kohler, who works with the American Astronomical Society, writes. You're the editor of Astronova, right? And you're one of the founders of Astrobytes, right? Did I get all that
Yes.
right?
Yep, that's right.
Whew. And man, it's a funny time. I was sort of joking about this earlier. It's the whole thing with the coronavirus has actually made things for me a lot more convenient because everybody now knows how to use Zoom, so that I'm having to provide almost no technical support for being able to get people into these interviews, and everyone is trapped at home in self quarantine, so everyone's able to do interviews. So just look forward to lots of interviews this week. So, Susanna, welcome, and tell us a little bit more about yourself.
Well, thanks so much for having me. Yeah, so as you said, I work for the American Astronomical Society currently. So my background is as an astronomy researcher. I did my PhD studying the relativistic jets that are emitted from the centers of active galaxies. And then when I finished up my PhD, the American Astronomical Society hired me to do science communication for them. So I work with the journals. So the AAS has a series of scientific journals that they publish, and the professional society as a whole, all of the researchers in it and beyond, many publish in these journals. And as we all know, when scientists publish papers, they're really intended kind of for the specific scientific subfield. But there are a lot of people beyond that subfield who might be interested in reading the work that's in these research papers. So my job is to go in and summarize some of the articles that are being published and make that more broadly accessible to the larger astronomy community and to the broader interested public.
Yeah, and I mean, Astrobytes is one of my favorite sources on the internet because, like as you said, like there's mountains of really interesting research that's being done and it's being published both in the prepress through archive, but also in all the different journals. And just a tiny fraction of that is actually making it out into the larger world. And a lot of that is purely because that whoever did the research just didn't have the ear of the press officer that day.
Absolutely.
And so reading through Astrobytes, can you tell us just a bit about how that works, and how you started this?
Yeah, so Astrobytes started a while ago. It's been nearly a decade, actually.
Yeah.
Started in 2010. It was actually a group of 5 graduate students at Harvard. I was not one of them. I joined like a month after, so I'm not technically a founder.
Oh, okay.
But when we started out, it was a
Early
really small,
adopter. Yeah.
yeah, that's right. And the idea really was that we were trying to solve a problem that we had all had as undergraduates, where it's really hard to get into the field of astronomy research because you start on your first research project and your advisor hands you this stack of papers and says, all right, go read these and then come back and we'll talk about it. And nobody ever trains you how to do that. And so the problem that Astrobytes was conceived to solve was this is just kind of an introductory step for undergraduates, a way of getting your feet wet in astronomy research without necessarily going out and slogging through those papers yourself. And it turns out there was a huge demand for this.
Yeah.
And in fact, we grew in authorship really quickly. Now we hire 30 new authors every year, and that's more fewer than are applying to be authors. Um, and we also grew in readership, and we did a reader survey a couple of years in to see, who are we reaching, thinking, yeah, we're writing these articles for undergrad students. And it turned out that the vast majority of our readership was actually graduate students, professional astronomers who just don't have time to
Yeah.
keep up with that huge flux of papers, like you said, that's coming out every day.
Yeah, I mean, you look through there's about 80 to 100 new stuff that's on archive, and that's pre-press, so it doesn't necessarily mean that it's going to be ending up on, in an actual journal, but it's pretty close. I mean, it's often I find if there's like a journal article is locked and I can't get access to it, I'll just go find it on archive, and it's pretty close to what the final science was for my purposes, as a journalist. But you look through the list, and you'll miss the important stories. Like because whoever is doing the research hasn't done a good job of telling the story of what it is that they've written. And yet, you go to when the press officer picks it up and goes, okay, what's our story here? Oh, okay, I get it. This is the farthest, this is the most powerful, this is the, the second ever, et cetera, et cetera. And it turns into a story that then you'll see on 100 different websites because someone got that ball rolling. And it's that gap that has always needed to be filled. And you're like the only ones filling it. It's so weird to me.
It is really strange. The thing that's so frequently missing from these is context. When scientific papers are written, it's usually without that context because it's assumed that the person reading the paper has it already. And that's just not the case if you're not already in that subfield. So what sites like Astrobytes and AAS Nova are bringing is that context, the broader picture of why this matters and what the main point is.
Yeah, absolutely. And so I think, for starters, I would love to hear your advice for astronomers who are, people who are in the field and want to get into the field, and how much should thinking about communicating their work play as part of their research?
I mean, I think that's a personal choice that everyone has to make as a scientist. Obviously, I'm biased, and I think that everyone should care about communicating their research and communicating it clearly. And I think that the field is kind of coming around to this. It's becoming a lot less taboo to talk about things like science communication than it was a decade ago, for sure. But
is it was it taboo?
I think there was this idea that there's no need to necessarily make your work accessible beyond the immediate researchers you might be collaborating with. And I think it's only now that people are realizing that it's important. I mean, even as a graduate student myself, if I go back and read some of the first papers I wrote, they are incredibly dense and terrible to get through. And I was an awful communicator because I thought that was what was necessary in order to prove that I was a real scientist. I have to write it in a dense, jargony, encapsulated way. And that's not actually the case. Scientists don't have to make that choice. They can actually make their papers accessible to begin with. But even beyond that, you don't have to write your paper necessarily for a general audience, but you can write a blog post about your paper, or you can find some other way of communicating about it. And I think that's a decision everyone has to make.
What about the recommendation about requiring that papers include some kind of lay person write-up as part of the paper?
I think that's a great idea. I wish that every journal did that. That's something that the journals at the American Astronomical Society don't do yet. I'm hoping that'll change in the future.
Yeah.
The question becomes, who writes those? Do the authors themselves have to write up something like that? And if so, how do you proof that?
Yeah.
Well, or do you hire people to write them?
I mean, you can even just include it as the synopsis at the top of your paper. I mean, I think, this is the part, and it's weird. I mean, I for all the people who I think do a really good job of both doing science, but also doing science communication, I keep bringing up this conversation with them, and I don't feel like I've really gotten a satisfactory answer, because on the one hand, you have this enormous public relations machine that exists to help publicize the work that's being done at the university, that there are real salaries, and there's a department, and there's people who come in every day and they do this work. And their job is to make the work of the university look good. And yet so clearly communicating the work that's happening at the university is meant to look good, and essentially to showcase the research that's being done. And yet there really is, I don't know if it's taboo, but it's definitely, even some of the best communicators I've talked to feel like it is not a necessary thing. In fact, it's there it is kind of not shunned, but frowned upon to be a good communicator of your science work. Like, that's a disconnect.
I agree.
Connect it for me.
I really do think that the attitudes around that are shifting. I think there are a lot more conversations about how this is an important component of, you know, of doing research, is communicating it. I think that definitely is the case in the current political spectrum, you know, trying to be better about getting this information out to lawmakers to make sure that it has an influence on the budget. I think there are more professional development programs available now, providing things like science communication training to scientists. So I think there really is a shift around the conversation with this, but there's
Yeah.
still work to be done.
Yeah, I mean, it even like, you know, there's a lot of people that wouldn't hire a Neil deGrasse Tyson or Brian Cox or you know, like these people who are very famous now communicators, but also astronomers in their own right. That is considered a downside if you're a good communicator, because you're maybe not a good researcher. Like, it's taking away from your research time.
Yeah, I mean, this is known as the Sagan effect.
Yeah,
After
yeah,
Carl Sagan. Yeah, and I really don't think that's as strong as it once was. I
right.
think we have made a big step
Yeah.
in that.
Yeah, because then I think you see a lot of people who have a real passion for science communication who are doing just incredible work, and like even like right now as we're going through this illness, this worldwide illness. Apparently, you know, YouTubers aren't allowed to talk about it because we get hidden from the YouTube algorithm. Anyway, everyone knows what I'm talking about. That what we need is clear science communication by the people who have done the work and understand what's going on, and yet. So anyway, you don't have my answers. I'll just keep searching until I find them. So let's talk a bit about, you know, I think that you are. I mean, you're a classic example of the person who started out in research and has shifted over into communication. So can you talk a bit about that sort of career journey that you took, and maybe what recommendations you have for people who want to be able to follow in those kinds of footsteps?
Yeah. So I realized pretty early on in grad school that while I really enjoyed astronomy research, the sharing of it was what I enjoyed the most. And so it was pretty clear to me that I wanted to take a track that would get me into a science communication job. At the time, it was maybe a little difficult to find information about what sorts of jobs are available in that field. But I decided to go ahead and finish my PhD because I wanted the experience of being a scientific researcher first before I went that route. So I did a lot of science communication projects on the side. You know, Astrobytes was one of those, getting involved in doing lots of science writing to get used to that. And then in 2013, I founded with a group of other STEM graduate students ComSciCon, which is a science communication workshop for STEM graduate students by STEM graduate students. And being involved in that really kind of gave me a lot of insight into what sort of options were available to me. So I would say that was kind of the point that launched me down that trajectory.
Yeah,
And I,
and you guys brought me out for one ComSciCon,
yeah,
which was a
2015, yeah.
yeah, it was a ball. I had a great time, and it was a lot of fun to be able to sort of see that next generation of science communicators. So how, you know, what you learned, if you could sort of, you know, I'm sure you get this question all the time, which is how do you recommend people, if they have that same feeling, which is like, I do love the science, but I'm more interested in sharing the science, what should they do?
Absolutely, just plunge into it. You know, that's the best recommendation I can give, because
Yeah.
once you start doing science communication in whatever form you can get involved in, whether it's, you know, writing for a website like Astrobytes, or having your own personal blog, or getting involved in a podcast, or going and giving talks at the planetarium, or, you know, there's so many different things you can do.
Yeah.
But once you start doing something like that, you meet other people who are doing it and new opportunities arise. And it's really amazing because the community of science communicators are just incredible. And,
Can
once you meet them,
yeah,
things come.
can people make a career out of this?
Absolutely. Yeah.
Yeah.
There are all kinds of careers you can make out of this. What really
I
amazed
mean, we've
me.
both got one. I mean, so
Yeah,
obviously.
exactly.
Yeah.
Yep. Yep. Absolutely. Um, yeah. So ComSciCon, we bring in panelists like you. So we have a whole bunch of professional science communicators who come in, and every year it's a different set of panelists. And so uh, it's been really interesting in being involved with ComSciCon every year, the last 7 years, seeing just the huge variety of science communication professions that are available, from, science writing, more traditional journalism, to being science consultants for Breaking Bad, or working in the film industry, or being a scientific
That's
illustrator.
a sweet job. Working
Yeah,
for,
right.
for Star Trek.
Right.
Yeah. Science
Yeah, yeah,
consultant.
super awesome. I mean, there's just like such a broad range of science communication positions out there, and you can definitely, make an entire career out of it.
Yeah. So the other part of your career, of course, is the work you're doing with the American Astronomical Society. And is that the bulk of your work now?
Yeah, yeah.
Yeah.
So I work full time for the American Astronomical Society, and the bulk of what I do is running AAS Nova, which is primarily the summaries of recent research papers that have been published in our journals. But then I also work with the publishing team, kind of improving the things that we offer through the journals.
And I mean, AAS Nova really feels like a blend almost between Astrobytes and a more press releasey kind of operation. So,
Yeah.
as the editor, what tone, what are you aiming for, and who's your audience?
My audience nominally is the astronomy community in general. The goal is to kind of take the results that our authors are writing up and make them more broadly accessible to the astronomy community. But oftentimes the papers that I write up are, at a level that astronomy enthusiasts can
Yeah.
absolutely read.
And
And
yeah, I mean, I often will draw on them for like videos that I'm doing. I'll use them as sources, references. So absolutely, I think it's definitely reaching out beyond just the professional astronomers.
yeah, yeah. I mean, I think the goal really is to just kind of take, the meat of a paper, boil it down to 500 words with enough context that you don't already have to know the field to know what's going on in it. And that works for most people.
And like, what percentage of the papers, of the journal papers that are going through your system are actually making it to Nova?
Pretty small percentage,
Yeah.
because we have a lot of papers. I think we publish more than 4,000 papers a year at this point. And Nova is publishing 3 articles a week plus a repost of an Astrobites article. So yeah, it's a very small
Yeah.
percentage.
Yeah. And don't you
Yeah,
feel like, I just feel sad for all of those
I know,
stories that,
because there's so much
yeah.
out there.
Yeah.
Absolutely. Yeah. I started out making the selections myself of which papers would be highlighted on Nova, and that was so challenging to begin with. Now I have the scientific editors of the journals send me their recommendations of the
Yeah.
articles that are like especially high impact and of broader interest. And even so, I have a list far longer than I can
Yeah.
cover.
And have you found that some of the stories that you cover have had the chance to break out to get a wider audience and sort of take a second life?
Yeah, yeah, some of them absolutely have.
Yeah.
It depends on the topic, and I specifically try to choose the articles that I know are not coming from somewhere where the authors are already working with their institute to put together press releases. Because I want to make sure one of the main points of AAS Nova is to bring attention to those research articles that would otherwise fly under the radar, that you would just miss otherwise because maybe the authors don't have an institute that has a strong press office, or maybe they don't even know that press releases are a thing, or maybe
Yeah.
it's undergraduates who have written the paper.
I mean, again, as my side as an editor and publisher, I don't need a full press release. And often I just need scraps I need to see a cool picture. I need to see a description of some behind the scenes of an interesting result that's been turned up with work that's being done. And that's often enough for us to kind of know that that is something that we want to follow up on. And that, I think, if I could communicate that to the people that are doing this work, is like, you don't need to go through the full, Hubble Space Telescope press release with all the pictures and the associated videos and so on. And so if the work is interesting, even just a hint of what's happening is fascinating. Like when we were covering the whole Betelgeuse dimming, we definitely got more news from Twitter from some researchers working in the field who were then going into tremendous detail about what was going on and what we think, and it was incredibly valuable for us to be able to put together a more comprehensive story.
Yeah, absolutely. I think the landscape of scientific research publishing is changing dramatically, and so having, first off, something like the archive where astronomers are publishing their preprints even before they're published in journals speeds up the timeline a lot. But now with Twitter, I mean, that's just whole nother level of speed there, where people are, as they're discovering things, they're putting them up on Twitter, and it's a way of really kind of getting that information out there so quickly. And yeah, like you said, being able to just grab pieces of that to put together the bigger picture is pretty awesome.
Yeah, I mean, it does rely on us kind of knowing what we're doing, but because I mean, at the same time, you see a ton of articles from certain UK newspapers about impending asteroid impacts, and they're obviously just like trolling through the Minor Planet Center listings or whatever, right?
The number of times I get inquiries, yes.
Yeah, I know, me too. So let's talk about the American Astronomical Society meeting, and this may not be directly what you're doing, but I'm sure you've been involved in some of the conversations. So,
Yeah.
Again, thanks to this stupid outbreak, it's having an effect on our lives. So what are you guys doing for the next meeting?
That is a great question. That's not officially settled yet, but the word that went out as of, I believe, yesterday, maybe the day before yesterday, is that we are definitely looking into the option of turning this into a virtual meeting. I believe, so the meeting was supposed to be in Madison, Wisconsin, and I believe the governor of Wisconsin, has limited gathering to below 250 people. So obviously, if that's the case,
3,000 is out.
Yeah, seems pretty likely.
Yeah.
Yeah, so assuming we move to a virtual meeting, it's still being discussed in terms of what kind of software, what kind of options are going to be available. But obviously the hope is to take this beyond, broadcasting the lectures, because that's not really all that a meeting is about. There's so much more to it. So
yeah, I mean, I can, having been to a bunch of them now, I mean, even I've definitely sat in meetings that were absolutely fascinating, and I know that I was getting access to information that none of my colleagues who weren't in that room just wouldn't know. So I think there's just value to broadcasting this information to as wide an audience as fits the AAS. Just that anyway, right? But now if it's not actually going to be in in set rooms, and does definitely make things more complicated. What tool will you use to broadcast? How will people be able to talk to each other, asking questions? How will you get the text to the question, so on and so forth? Yeah, the logistics will be tough for sure.
Mm-hmm. Yeah. But Astrobytes, one of the things that they've been doing now for years is live blogging these conferences. They'll go and there'll be a team of 5 or 10 Astrobytes authors at the meetings, going around to the sessions, and then they'll write up summaries of the sessions afterwards. And I think there's still absolutely the opportunity to do that in this context. In terms of the poster sessions, we were actually planning already this summer to have, for the first time, go to a fully iPoster session, no physical paper posters. We've already at previous meetings had a substantial fraction of iPosters. And so this was going to be a trial of like, go fully e-poster here and see what happens. And so this is actually kind of cool, because we're already set up in the infrastructure of that to have all of the posters online, be able to hopefully do some sort of interactive means of viewing all of those and discussing with the authors.
Yeah, and that's what I think we're experiencing now is, again, unfortunately, we're all being forced to work from home, and necessity being the mother of invention, people are figuring out ways to work together in new ways. And my guess is that some of these are going to end up being so convenient and so that are going to work well that they'll keep doing it even after they're allowed to come back into their offices. And it could
Absolutely.
very well be. I mean, I got a chance to try out the eye posters when I was at the last conference, the one in Hawaii, and it was great. I loved it. The person would stand beside their screen, and they had all the information that they needed required, but you could also browse through them. It was a great system, and you could definitely see it just being on the. I mean, just the whole idea of the poster is so weird. So
Yeah,
in the age of the
absolutely.
web browser, so
And I mean, it's cool to be able to incorporate elements that you can't otherwise, like videos. I mean, that's neat to be able to have that as a part of the poster experience.
yeah, yeah,
And
um,
as you said, I mean, a lot of this, is stuff that has been in conversation before. I mean, from a sustainability standpoint, we've been talking for years about, how can we reduce the carbon footprint of these meetings? And it's been, virtual meetings have been floated in the past, but the technology just wasn't there. And I think now that's going to be catching up real quick with the current situation.
Yeah, it's a tough one because there is a tremendous amount of value to being in the same place together to talk. For us, we can run around with a camera and interview people all over the place, which is great. For but for a lot of people, they feel bad about traveling that far and
Yeah.
uprooting themselves. And it's for the longest time we didn't actually attend them, just because it was such a lot of work to get there and get to and from the hotel every day. It's
Mhm.
tough to
Absolutely.
you
Yeah.
know so I think that'll be great. I think and I hope that some version of it runs like an enhanced virtual version runs. But I guess it's just a couple of months to try and figure this out if that's the
Well,
plan.
yes and no. I mean, I think we're not necessarily tied to the original dates either. So,
Yeah,
you
if you
know,
have to.
but yeah, we'll see. But yeah, I think there's a lot of hope amongst the staff right now that this is also an opportunity as well as challenging.
Yeah. I got a couple of questions here. This comes from Veronica Cure on Twitch, which is, what is the point of research if the results aren't shared? And this is sort of back to the original question that I'd asked you. Um, what do you think about that?
Absolutely. I personally agree. I think that sharing the results, I don't know that anyone would argue that sharing the results is not necessary in any format,
Hmm.
but I think people differ about how far those results need to be shared. And I personally agree that they should be shared broadly to everyone because, this is valuable information that everyone should have access to.
Yeah.
Yeah.
I mean, we're in this environment where some pieces of research are freely available and others are behind paywalls. I don't
Yeah.
where are the American Astronomical Society ones on that
Mm-hmm.
spectrum?
So they are paywalled for 12 months and then they're completely free. It's a green open access model.
Right.
But you're also allowed to publish the research that's been published in the AAS journals to the archive, the preprint server, at any time. So basically, it's the go ahead to make this freely available immediately. And the only reason it's behind the paywall is for the first year, is so that we have some sort of income to keep the journals going.
Well, that's the question, right? Which is like the the journals. I mean, like Nature and Science and all of this, right? Their revenue is the subscriptions that are paid to print up the journals and send them around, and they have tremendous expenses. They have the peer reviewers, they have all of the printing and coordination expenses, etc.
Mm-hmm.
And from their perspective, you can absolutely see how they want to maintain that model. And yet, for a lot of people, they have this position that science should be free, freely available. That you're really uncovering information about nature, um, but it took a lot of work. So
It's a major challenge.
yeah,
This is a problem in general, right? Because when you're running a journal, it does cost money, not just for the printing expenses, but like we've got data reviewers, we've got statistics reviewers. There's just like a ton of, and like it pays my salary, of course. So I'm biased
yeah, of
here.
course, of course. Yeah,
Yeah.
no,
So you can't do all of that for free, but then you don't want to make the cost of accessing the information too high, but you also don't want to make the cost of publishing the information high. So some journals have a business model where the fee all goes on the author. It costs to publish. Some journals have a model where the fee all goes on the subscribers. It costs to read. Some journals have a hybrid model, that's the AAS journals, where it's a small amount to subscribe and a small amount to publish in. And that way that can kind of be adjusted based on whether university grants are tight or library, money is tight or that sort of thing.
With what the way I run Universe Today is, we have advertisements on the website, and then we also have Patreon, and it's about like 25% Patreon and 75% ad revenue.
Okay.
And I see a lot of people starting to go behind paywalls for their publishing their websites, 3 articles and then you have to sign up, or Wired has gone behind the paywall, and Discover. Anyway, there's a bunch that are starting to go that route, and more are clearly that's the trajectory they're on.
Yeah.
And my feeling is really that it's our, like, knowledge should be free, and so it's really hard for me to justify putting the work we do on Universe Today behind a paywall, and because I want people around the world to be able to access it. And so that's the value. That's why, that's what the Patreon does for us, and the ads go a long way as well. I would love to get to a point where we can even remove the ads and just go with pure Patreon, right? But I'll never go paywall.
Yeah.
And the way I make that work is I'm just incredibly cheap and work from my house,
Yeah, absolutely.
and drive an old car, and you know what I mean? Like,
yeah.
that's I think and so I think that's a decision that more and more of these sites are going to have to make. And I don't think that there are necessarily there's a lot of room for New York Timeses and Washington Posts, etc.
Yeah. And AAS Nova, of course, isn't paywalled. That's completely free to access. It's just the articles that are paywalled for a year. But yeah, absolutely. I mean, and it's true that right now the academic publishing landscape is changing a lot as well. There's been a real movement towards open access, and that is definitely causing a shift in the landscape, because if all of the government funding agencies start mandating that academic researchers can only publish in open access journals, that will kind of force all of these journals to move to a model where then they have to charge author fees,
right,
in order to stay afloat, right?
Yeah.
And so it shifts the burden, and we want to make sure that authors who are at institutes that don't necessarily have a lot of funding, or they don't have a lot of grant money, aren't necessarily precluded from being able to publish. But we also want to make sure that the research gets out, because that's the point.
Yeah. So, I mean, what are some other models that you like? Someone, Arjun, is asking on YouTube, could scientists have Patreons for publishing? So, I mean, has anyone looked into those kinds of models?
I don't know.
Yeah.
I'm not sure. That's not something I had ever, like crowdfunding scientific research is not something I have heard much about.
Yeah, there have been a few projects to do that. My concern is that it'll fund the panda bear cuddling research, but not necessarily
and planet hunting.
And not necessarily some of the more obscure. So I think that it's tough to try to turn science into a popularity contest, because a lot of the most interesting discoveries come from, not um, super sexy,
On
parts
the
of
other hand,
science.
maybe it's going to make scientists better at communicating their
Yeah, of
research.
course. Yeah, maybe we brings it all around.
Yeah, yeah. Yeah, no, definitely. That's absolutely a challenge. Some journals do have a different model, which is that they're funded by the government, and that would be grand because that solves all of the problems. But the likelihood of that happening here anytime soon is low.
So, I mean, like if you're a scientist and you're looking for, say, grant money, do you have to set aside a budget for like a fee paying journal if that's the path you're going to take?
Yeah, effectively, you have a publishing budget, assuming that the journals you regularly publish in charge a fee. And some journals, so AAS journals offer an option of gold open access. So you basically pay more upfront as the author to absorb the fees of reading it for the readers. So that means that when you publish, your article will be free immediately to everyone to read, but you have to pay a little more upon publishing it.
Yeah.
So if open access is something that's important to you, you might budget a little more in your grant proposal for publishing gold open access.
Yeah. A question from, let me see, there's an interesting question just came up. It's from Nekog One Earl. Do you need a degree to get into science communication?
I think there are a lot of different paths to
Mm-hmm.
get into science communication. And I think that's part of what makes it a really interesting field is that it brings together people from a whole lot of different backgrounds and they all have different strengths and skills as a result. So I think one route is going in the way I did, get a PhD in science, get a degree in science of some variety, and go there. But another route is being trained as a communicator or as a journalist or as an artist or any number of other fields that you can go into and
Mm-hmm.
then have a specialty in science. So
Yeah.
I think that depends.
Yeah, I mean, I think from, definitely I'm the perfect example of someone who didn't get their degree in astronomy, mine's in computer science.
Mm-hmm.
And I definitely didn't have a degree in writing or communication or journalism or any of that. That was just practice, right? And that's my advice on that is always just do the work and
Yeah,
you'll eventually get good enough to that people will take notice.
exactly.
Yeah.
Absolutely. It's a lot of just go out there, try it, figure out what you like and what you don't like, because that's an important part. You might think you want to do a thing and then you start doing it and it turns out the day to day sucks. So that's definitely important to know sooner rather than later.
Do you
But
find with with the Astrobites people, the alumni, do they, what percentage of them keep on with their science communication and which, just focus on the research?
I don't have an actual numbers breakdown I can give you, but just anecdotally, I know that the alumni of Astrobites have really gone into a pretty broad range of fields. A lot of them have stayed in academia and are now faculty at R1 institutes. Some of them have gone into teaching. Some of them have gone, like me, into science communication fields. So it's kind of cool that it's resulted in this pretty broad range of outcomes.
Another question from Arjone: how does one gain clout as a science communicator?
Ooh, you
Yeah.
can probably answer that better than I can.
Yeah, I mean, from, I don't know, do it for 20 years?
Yeah, I mean that's
Just
yeah,
keep.
do it for 20 years, build a following.
Yeah, yeah.
Yeah,
I do think though that it is important to put some emphasis on the building a following, on being available and being accessible to the audience if that's a thing that you want to be able to do. So you definitely want to have a social media presence so people can tweet at you to send you messages and publish your email. Like that's the part that I find sometimes a little frustrating is, I'll try to find a person behind a story who is clearly good at what they're doing and they just make it so difficult for me to find out who they are. right?
Yeah.
Someone publishes just a beautiful infographic, or they do this great cartoon, or I really love when people will go to like conferences and they'll draw really intricate sort of sketches of the research that's being done, and they'll post it on Pinterest, and I'm like, who did this? Because you don't want to, you don't want to steal it, so you've got to
Yeah,
get
of
to the
course.
source, and they make it really hard for me. So, like,
Yeah.
man, just like stop making it difficult for people to find out who you are. Like, just start there, and then move to actually trying to develop a following. But I don't even know what clout means. Like, what is clout as a science communicator?
I mean, I think a component of it is having credibility, and then a component of it is getting your work out there. And those are both tough.
Yeah.
It's, I think, as much a game of chance as anything sometimes. Astrobites really took off after Phil Plait, Bad Astronomer, posted about it or tweeted about it or something, and all of a sudden then Astrobites had a readership, and it grew exponentially from there. But it took that first seed of just somebody who was willing to kind of give us a little bit of a plug to build it into something as big as it is now.
Some of the CosmoQuest folks are telling me that I should point out that you've got a sticker on your wall behind you there somewhere.
Oh, you bet I do. Absolutely. Yes. Many, in fact.
Yeah, exactly.
But
Yeah. Yeah, it's
yeah.
hard to come back from a conference. I have snowdrifts of stickers from the last conference piled up.
Yep.
Um,
Yep.
um, so Flask on Twitch is wondering what life was like at UC Boulder. How was that as a school?
Oh man, I loved it there. I want to go back. Yeah, Boulder is great. It's I mean, Boulder as a location is amazing, but the program there is really, really great. It's a large program. Um, and so that was part of what appealed to me when I started out there, is I didn't quite know what it was that I wanted to research yet. And they researched so many different topics that I knew that even if it took me a while to find the one that clicked with me, I would be able to find it there.
Yeah,
But yeah.
Phil Plate's living in Boulder. I got a chance to visit him once, pre goats, but it's a beautiful town, and with a just incredible kind of mountains, just over, sort of right over, sort of over the top of the city, and just amazing landscape all around it, and really cool vibe to it. I can see
Yeah,
why ending
absolutely.
up in
It's
that
gorgeous and
town.
everyone's outside all the time.
Yeah,
And, if you want to skip research for an afternoon to go skiing and then make it up later, nobody's going to bat an eye. It's pretty great.
yeah, and following up on the seeing the Morecambe Mindy House, we, we did we did that as well.
Uh-huh. Yep. Yeah.
Yeah, um, cool. So let's talk a little bit more about your research and how. I mean, obviously, I'm assuming you've been following the work that's been done. So let's talk a bit more about like what you researched.
In my PhD?
Mm-hmm.
Yeah, so I looked at the structure that jets take when they're emitted from the black holes at the centers of really active galaxies. So we see these black holes are spewing out jets. So when matter accretes onto a black hole, a lot of it gets actually flung out in these jets. And instead of spraying out in all directions like a garden hose, they're like super collimated, and we want to know why. And so my research was looking at what sorts of interactions with the environment these jets might have that would make them collimated.
And when did you do your work? Like when did you publish your
So my work
papers
was,
on this?
so I graduated in 2014. So my work was like 2011, 2014-ish.
Right. Okay. Okay.
Mhm.
And
It's been a
so, do we know the answer now?
while. We know more pieces of it for
Yeah.
sure. We definitely think that the pressure of the environment makes a difference, but more and more, it's pretty clear that magnetic fields play an important role. One of the big sets of questions we're trying to answer is how do these jets get launched in the first place? And then why do they take the shape that they do? And all of that can kind of be answered with magnetic fields.
So just to be clear, right? We've got the actively feeding supermassive black holes at the hearts of various galaxies, and they're getting these gigantic accretion disks around them of material that's waiting to join the the meal, and then you get these incredible jets that are moving at a significant fraction of the speed of light, right
Yes.
at the poles of the black hole.
Hmm.
And so, how?
Yeah,
Why?
exactly. That is the question we're trying to answer.
Yeah,
So you can construct a scenario where this black hole is threaded by magnetic fields, and as you twist those fields up, that process is providing a place to channel the material out and up to launch this jet and send it out into space. But that's the open question that we've been trying for decades to solve. Is like, what is the actual process for this? And it's really difficult because simulations of this just are incredibly computationally expensive to involve all of the physics that takes place in this sort of environment. It's just really hard to do so without like cutting out all of the complicating factors, but the complicating factors are probably the things that make it work,
right.
right?
I
Yeah.
mean, what is the cause of, like, what is actually causing the magnetic field in the first place? I mean, I guess I'm kind of imagining like the sun has a magnetic field, and the accretion disk around a black hole is sort of just like a lot of suns all mashed up and spun around a black hole, right? So whatever happens in the sun just happens more extreme in
Yeah,
those
so I
regions,
mean
right?
this material is magnetized itself, and you've got this tangle of magnetic field lines, and it's just all it's a big complicated mess. And that's part of the question, is trying to figure out like, how magnetized are black holes? How magnetized is the environment around them? What happens to these field lines as they get twisted up around the black hole? uh, does reconnection happen? Do the field lines break and reconnect in new ways and release energy in the process?
I mean, kind
Uh,
of like we have flares on the sun, right? Is like
exactly.
that
Yeah.
exact kind of environment,
Yep. Yep.
except to
A
the
lot of
extreme.
stuff
Yeah.
that's really hot and probably really magnetized, and we're trying to figure out what happens to it in that state. Yeah.
Um, how was it? How did it feel seeing the first pictures from M87?
That was really cool. Yeah, that was awesome. And it was also really cool how cool everyone else found it. Right? Because I like, this came out and I'm like, oh my gosh, this is amazing. And I'm thinking like everybody's gonna be like, oh, this is such a disappointing blurry blob, right? And everyone else is like, wow, this is amazing. We're looking at a black hole. And it's so cool that this story just really traveled all over the
Oh
world.
yeah.
Yeah.
Um, and when we're still waiting for Sagittarius A star,
Hmm.
it's close up. Do you have any inside knowledge on when we might see that?
I don't. I am anxiously waiting with
Yeah.
everyone else. Yeah, I really hope that they are. I recognize that it's a more challenging problem.
Yeah, I'd heard that one of the big problems is that it's a much more dynamic environment. While,
Mhm.
M87 is so far away, you're seeing blobs take weeks
Yes.
to go around the black hole, while at Sagittarius A star, you may have them happening in the matter of minutes, which,
Yeah.
it's
Yeah.
kind of a,
The difference is that it's the size of the black hole. Because M87 is so large, the time scales are longer, whereas our black hole is big, but it's not that big. And so the time scales are faster. So there's a lot more variability. And it's, also we're looking through the galaxy to see it, which is complicating matters as well.
yeah.
So it's definitely a little more challenging to observe, but I sure hope we can do it.
I mean, what do you think the future holds then for this kind of work? Like, what is some interesting research that's being done in this field now? I mean, I'm assuming every time you see a paper from the people that you recognize, the people that you worked with, the people who are chewing on this problem beyond where you took it, what is some of the sort of cutting edge work that you're really fascinated about right now?
I mean, really, the stuff that evolves rapidly is computing power and numerical techniques that allow us to do, increasingly more realistic simulations. And that's part of what's really exciting. Finally, getting the observations from the Event Horizon Telescope is now, the simulations have even more to compare to.
Right. Okay. Because you can sort of verify that what you were simulating is essentially correct.
Yeah, absolutely. So my research is as a theorist. In fact, everything I was doing was actually pen and paper, just like working out the math.
Right.
um, but in terms of people who do that, people who do simulations, like you can make a lot of advances in terms of understanding how you think things work. But until you can compare it to new observations, you can't take that next step to say, okay, now let's try something more complicated. And really having these observations means now we can do more complicated simulations and see how that compares and learn more from that. So it's constantly a game of catch up, you know, of theory getting ahead of observations and then observations getting ahead of theory, and you just kind of leapfrog back and forth and learn from that process.
Although it is kind of amazing the amount of progress that has been made. Have you gone back and watched Cosmos, like the original Carl Sagan Cosmos, anytime recently? Like I think
Yeah.
like in the first episode they talk about quasars and like we don't know what quasars are. Maybe they're this and maybe they're that and maybe they're black holes, but we don't
Yeah.
know. And then you're like, Carl, we do know. We do know the answer. um, and then and then this idea there's like three different kinds of objects. There's like quasars and radio galaxies and realizing that it's all the same object, just seen at different angles. So
Yeah.
so
Yeah.
like we really are making a tremendous amount of progress, and yet the work is sort of still tough. Black holes are apparently not giving up their secrets very easily.
It's a slow process. It is interesting though, the way that processes around black holes seem to scale up, right? So I just mentioned like the difference in size between M87 and our black hole, Sagittarius star. But then you can scale down even smaller to like stellar mass black holes. And the activity there is much, much, much faster. And so there's a lot you can learn by looking at in real time the activity at a stellar mass black hole and then comparing it to looking at a large sample of supermassive black holes and seeing them at those different stages individually. So even though you can't see like the real time environment changes and whatnot,
Mm-hmm.
you can see black holes in different stages and compare that to the real time stuff. So it's neat to be able to like have this basis of comparison across different mass scales and time scales, and that's something that's we've really expanded on in
Do
recent
we
years.
we see those jets from the stellar mass black holes as well?
We do, absolutely, yes.
Just
Yeah, so
not the
like
same.
X-ray binaries, for instance,
Yeah.
you've got a black hole in an orbit with an ordinary star, and that star is donating matter into an accretion disk. So then that's accreting onto the black hole, and you get jets from that. And all of this is, like the theoretical work that I didn't actually have a scale. Like you could picture it as a stellar mass black hole or as a supermassive black hole because the processes we expect to be all the same. It's just it scales up with the mass of the black hole.
Right. And the amount of material but I guess the mass of the black hole sort of is defined by the amount of material that's making its way into it.
Mm-hmm.
Would this be a way to find primordial black holes by maybe them flaring briefly as the jet is passing our point of view?
Yeah, so I mean,
It's like
the
almost like a standard candle.
yeah, so like tidal disruption events are basically that, right? It's that you've got black holes that aren't currently accreting matter or weren't accreting matter, so you couldn't see them because if a black hole doesn't accrete anything, that's the only thing that makes it light up. A black hole that's not accreting is just sitting there, it's dark, you're looking at it, you don't see it. But as soon as it starts accreting matter, that matter, as it goes around and around and around, as it spirals into the black hole, it's giving off X-rays. And then we can see that. And then it might have a jet, and we can see that. So if you've got a black hole that's sitting out there, and then a star passes by, and suddenly that black hole has a meal it didn't have before, then it's going to light up. So
Right.
that's what we're seeing now. We've started to discover these tidal disruption events, we call them, where a black hole that we didn't see before suddenly lit up. And it's like, hey, it's now eating something.
And is that because it's in a binary system with another star, or is that because it just happened to make a close flyby of a star system and snacked on the star as it went by?
Typically, I think we think it's the latter. I think there are
Really?
instances of, yeah, I mean, it's stuff in space, and sometimes things pass a little too close. I don't know if you remember all the fuss around G2, the gas cloud
Mm-hmm.
that made
Yep.
close approach to the black hole at the center of our galaxy a few years back. And like, there was a lot of excitement around that because we were hoping that this would come in and be like this snack for our black hole. Our black hole is usually very quiet. We don't have jets coming out of Sagittarius star, but we were hoping that like when this gas cloud came in, maybe it would get a little more active and we would see that increase in activity, and that would really kind of solidify our theories of how this works.
Right. That's really interesting. Yeah.
Yeah.
But I mean, in that situation, I mean, people always ask, like, can a black hole come through the solar system and what would it cause? And, yes, and awfulness are the answers.
Sure.
But the fact that the planets orbit the sun nicely and have
Yep.
done so for 4.5 billion years sort of tells us that clearly it's not a very common, it hasn't happened yet.
Yeah,
I like our
exactly. And
chances.
it's also important to remember that a black hole doesn't actually suck stuff in. It, if our sun turned into a black hole tomorrow, we would just keep orbiting around. Like we wouldn't get sucked into the sun.
Yeah.
We're in a stable orbit where we're at. It would get a little colder, but nothing else would change. So yeah, black hole, depending on the size, has to be pretty close to make an impact.
Yeah. But a black hole wandering, making its way through the solar system and back out again would cause a certain amount of mayhem.
A little bit.
Yeah.
Yeah, maybe.
Yeah. But I mean, the fact that, again, like the fact that the planets orbit the sun nicely tells us that it hasn't happened yet.
That's
right. Awesome. So as we start to wrap things up here, where can people, one, get involved with some of the projects that you're working on? If you're a graduate student, like at what point should people start reaching out to Astrobytes and trying to get involved?
Yeah, so astrobytes.org is the website, and we do a hiring call every fall. I say hiring, Astrobytes authors don't get paid, but we invite astronomy graduate students to apply in the fall, and whether or not you're selected to be an author, if you're interested in writing for Astrobytes at any point, we do accept guest posts. There's a little link at the top of the page on the homepage that says submit a guest post or something to that effect. And we're always happy to hear from people and have them suggest posts that they want to write about.
Yep.
Yeah, so that's the main way.
And then with Nova and the journals.
With Nova, so I don't currently have a guest author program set up. The main way that somebody might be involved in Nova is that we have a AAS Media Fellow is the position. So that goes to an astronomy or planetary sciences grad student and changes out every year or 2 years, depending. So that's a position you can apply for if you're interested in doing writing for AAS Nova and also working with the AAS press officer, Rick Feinberg, to do more press-related things.
And you recently acquired a magazine. Are you working on that at all, or is that hands off so far?
It's hands off so far. I think we've been talking about ways of increasing our collaboration. But yeah, absolutely.
Yeah, we've got a lot of people that write for Universe Today who also write for Sky and Telescope. So I can definitely, they're definitely
we're really excited about that.
Yeah, it's great. I'm so happy that Sky and Telescope found a home with the American Astronomical Society. Seeing that Rick was the original editor of the magazine, and to see that he's been able to sort of get a chance to do this again through his work through the AAS is wonderful. So
yeah, we're really psyched. It's nice to have another outlet through which we can be a part of the amateur astronomy community in particular. Yeah.
Well, Susanna, thank you so much for taking the time to chat with me today. I really appreciate it, and I hope you have a relatively painless and safe quarantine over the next couple of weeks. And I look forward to seeing what happens with the AAS experiment if you guys are able to pull this off as a virtual meeting.
Absolutely.
Keep me posted, of course. We'll be reporting on it. All right. Thanks a lot.
Thanks.
Bye.
Take care.